consider in our study of ionic bonding is something called the polyatomic ion. So that's the big word we use to describe it. And now we'll write it down, and then we'll just go through how it works and how we deal with it. The word polyatomic means multiple atoms. Poly, multiple or more than one, and atomic, atoms. So these are little groups of things that have more than one atom in them, but they behave like they were all just one big happy ion. Okay? And so there's a bunch of them, and we're going to learn them sort of slow and steady, but let's just write that down. So a polyatomic ion is a group of atoms and it's usually non-metals. That's kind of important. So let's put that down. Non-metals that are held together by what we call covalent bonds. Now, the weird thing about studying chemistry is, you try to start at the beginning, but it's difficult because you kind of have to jump around a bit. We haven't learned really a whole lot about covalent bonds yet. In grade 9, you might have touched on it. We also call them molecular bonds. And so this is a different kind of bonding, and it involves the sharing of electrons rather than the forming of ions. And so what we're going to do is we're just going to pretend that they stick together and not worry about it until we get into the next part of our unit where we'll study these bonds. So they're held together by covalent bonds. And I'm going to put a comma here. Actually, I don't need a comma there grammatically, so I won't put a comma. But the entire group is charged and acts like an ion. So it's kind of a 2-in-1 type of thing. It's got a different kind of bond inside of it, but we don't really have to worry about that because as a group, as a big whole thing, it still acts like an ion, and it still is able to make ionic bonds. And the reason for that is because when they get together in these little groups, the number of electrons is not quite enough to make them perfectly stable. They need to bond with something else in an ionic bond in order to sort of become as stable as they can be. All right? So far, so good? Okay. So, they come in different types. So let's call them type 1. Doesn't really matter. That's not an official term. It's just what I'm going to call them. Type 1 is when we get a non-metal plus oxygen. So that's what they look like. So I'll give you some examples. The problem with these is it's difficult to find a real pattern that we can use, and you have to kind of memorize a lot of these, or you use them so often they become common knowledge. They're not on the periodic table. I mean, the atoms are, but the groups of atoms are not. And so you kind of have to just get used to them and get familiar with them, okay? And so let's take a simple one. Let me just go up here. Simple example. Oops, where's that? So if we take nitrogen, and we have 3 oxygens, so NO3 like this. And because of the way that the oxygens are hanging on to the nitrogen, this group has a charge of -1, and we put a minus right up there to show that. Okay? Now we have to give them special names. And so we call them, this one is called nitrate. And the key here is to focus on the 8. The 8 at the end is a suffix that tells us we're talking about this particular polyatomic ion. It's the one that, so it's almost like the oxygens there translate into the 8, nitrate. Now, when you use this polyatomic ion, you have to remember that this part is all stuck together and it will never change. When you start to do a crisscrosses and you combine it with something else, all right, you cannot mess around with this. It sticks all together. You could almost imagine this to look like this with its little negative charge. The negative charge up here at the top is the only thing that we're really going to work with. Okay? But the problem is there's lots of numbers and they get a little confusing. So let's see what would happen if we took this nitrate and we wanted to combine it with something. Let's see what would happen if we took lithium and we wanted to combine it to this nitrate. But we have to kind of memorize that's what nitrate looks like. There's no way to really figure it out other than just knowing. And not only do you have to memorize the atoms that are in it, but you have to memorize the little charge number of -1 as well. Now we know about lithium, right? We know lithium is a +1 because he's in the first column. So we should be able to do a crisscross. Okay? And so what we do is we crisscross the 1 down here like this, and we crisscross this one over here down there. And because they're 1s, we don't show them, right? But there is a bit of a problem. Look right here. How do I cross a 1 down there and it doesn't interfere with the 3? It'll look like 31, right? I can't write this because it doesn't look right. See, that little number that hangs there, we can't touch it. We can't mess with it. It's part of the group. And we have to somehow understand that that number has to be separated from the number we're going to cross down. So what we actually do when we crisscross is in our heads, we kind of do this. We cross the 1 over here from the nitrate. That's the one going this way. And then you have to envision the nitrate over here, and there's a 1, but it means 1 of the whole thing, 1 of all of this. But since 1s don't matter much in chemistry, if we cross a 1 down and we cross a 1 down, we could just ignore them because the 1s are implied, right? When we write Li, that obviously means we have at least 1. So there's the formula, lithium nitrate, and the 1s don't need to be involved. We can just imagine that they're there. So if we were to do a whole bunch of combinations here, let's go down the column. We could take potassium plus nitrate, -1 plus 1. So when you crisscross them, the 1s that are crisscrossed down don't seem to matter, and we get to there. That's potassium nitrate. Notice it's not potassium nitride. See the difference? This is potassium nitride when you combine it with just nitrogen. Ide is when you're combining with a single atom. But we have to use our new word with the suffix -ate. So this one would not be called potassium nitride. It would be called potassium nitrate. Okay. So that seems to work okay when you have 1 and 1. But you can imagine there might be other numbers, right? Like what would happen if we tried to combine magnesium with nitrate? Well, let's see what happens. I know that nitrate has a -1 charge. I memorized that. And the magnesium is 2+. Now I have to cross the 2 down. Okay? And so when I cross the 2 down, I get this. I'm just going to write this magnesium. The 1 goes down here, so I don't need to write anything after magnesium into 1, right? But now look, now I have to write NO3, but now I have to put a 2 down here, and it looks weird. 32, is it? How do I keep it separate? And the simple way to do that is to put brackets around the ion to separate the 3 from the 2. So we use brackets here to keep the group together. so that the numbers don't interfere. So what this means then, remember, we do the crisscross and then we forget what it means. What it means is this. Nitrate ion is -1. Remember what -1 means. It means you have an extra electron that you'd like to get rid of. That's what it means. Fluorine is -1. She has the extra electron to get rid of. So that's what it means. And magnesium is +2 because it wants, actually I said that backwards, didn't I? Now I just realized that. Some of you nodded yes and nobody said no. You got to correct me when I'm wrong. The minus doesn't mean that the minus means you're looking for an extra electron, right? The plus is you want to give it away. So in other words, these charges are what happens after. Right? Fluorine is minus because she usually takes an electron from someone else. So after she does that, she becomes a minus. That's the way I should have said that. Sorry about the confusion. But it means that what happens is these electrons here somehow have to go over there to make them 2+. You can't become 2+ unless you give away 2 electrons. Well, a nitrate only wants 1. You see the -1? So we need to have 2 nitrates available so that one of the electrons can go to this nitrate up here and the other one can go to that nitrate over there. So to make this group, what we're saying is we need 1 magnesium atom and 2 of the nitrates. And so you can see by putting the brackets there, we now have indicated 2 of nitrates. That's what it means. There are 2 nitrates. We could imagine it like this. Whatever's in the brackets is just a happy face. And there's 2 of them. Right? They're just 2 big blobs. Okay, so let's do a couple of other examples of this nitrate and how it might work. Let's do beryllium nitrate. So if we have Be and we want to combine nitrate with it, well, you can see from these numbers, 2+, because beryllium's in the same column as magnesium, column 2. You can see that if beryllium is going to give away 2 electrons and become 2+, you would need 2 nitrates to take those electrons. Each would take 1. And so when you crisscross, you would write Be. The 1 comes down from the nitrate, but you put the nitrate in brackets. You'll notice we didn't need the brackets last time. 2 there. We didn't need the brackets way up here because there was only 1 nitrate that we needed. What this means, if you look at it, is 1 potassium atom right here can give an electron to 1 nitrate and make everybody happy. So we didn't need any brackets because there's only 1 of each. It's only when you have more than 1, like a 2 or a 3 or a 4 or a 5, where you need to put the brackets. So now we could combine one of our multivalent metals, right? We could say, okay, let's do iron 3. If it's called iron 3, we know he's a 3+. And let's put that with nitrate. Okay? I didn't write any names here. Maybe I should have. This one up here was called beryllium nitrate. Nitrate, because that's the ion. And this one down here, if we crisscross, well, watch. We write the Fe. The 1 right here goes down, so I don't need to write it. And then the 3 over here has to go down. So I have to put brackets because that means I need to have 3 of these nitrates. And I don't care about this 3. This 3 has nothing to do with it. That little hanging number is just part of the group. It just means that there's 3 oxygen atoms hanging out with the nitrogen in this blob. But we don't mess with that. We put our 3 over here where it belongs, and that's our formula. And we would call this one, we'd have to combine our rules, we would call this one iron. And now watch this, iron 3, remember how we do, it's a multivalent metal, and then nitrate. So now you might get confused because we're using brackets for 2 different things. We're using brackets for a Roman numeral for one thing, and now we're using brackets here for another thing. Not the same brackets. They have a different purpose. It's not the same thing. So we have to be careful. Now it starts to get confusing. Where I put the brackets, where do I put things? And it becomes a bit complicated. Okay. Now, that's nitrate. That's one polyatomic ion. There are many. And so what we're going to do now is make a little list of some of the most common ones to start. And then I'll introduce you to, in another video, I'll introduce you to all of them. But that's too much for one day. So let's just take a look at some of the most common ones. So there's a group of atoms like this called nitrate, and they have a minus charge. So that's what we call nitrate, right? You could write these in a little chart. Nitrate. There's another one called sulfate. It's an S with 4 O's attached to it, and it has a 2 minus charge. It would like to grab 2 electrons from somebody else. That one is called, can you guess what that might be called? It's, the 8 is for the oxygens, and the S is sulfur. Very good. Sulfate. Sulfate. Perfect. Let's do another couple that we might come across. Is my phone ringing? Sorry. Let's do this one. There's a one where carbon combines with 3 oxygens, kind of like the nitrate did, but in this combination, it's a 2 minus. What do you think that one's called? Carbon 8. Carbonate. Carbonate. The carbonate ion. So why don't we put ion after each of these? So we know. Okay? Ion. Okay. Let's think of another one that we could use that's going to be fairly common. There's one with a P, that's phosphorus, PO4, and it has a 3 minus charge on it. That one's called phosphate, phosphate ion. Very common, phosphate. Another common one is chlorine. O3 with a minus on it. And this one is called chlorate. Chlorate. It's only a -1, like nitrate. That's called the chlorate ion. Okay, so far we see we've got nitrate, sulfate, carbonate, phosphate, and chlorate. Those are some of the most common ones. There are many more, and I have a chart that I'm going to give you. Let me just have a quick look there to see if there's any more that... I think those are a good starting point for us. We'll learn the rest later. So we'll start with these 5. Okay? And I'm going to give you... no, we won't get any more complicated than that. There are some polyatomic ions that have a positive charge. And we'll talk about those later. But for now, we'll just look at the ones that are negative. Okay, so now we have this list. So keep it in front of you. Let's do some examples. Let's just do some examples and run through how to use these. Let's just combine a bunch of them, and we'll try them together. So what I want you to first try to do is do potassium and phosphate, and see if you can figure that out. Remember, potassium is K, right? Not P. Don't confuse potassium with phosphorus. So do potassium plus phosphate. Let's do lead. We'll do 4. Lead 4. So that tells you what kind of ion it is from before, right? Let's combine lead 4 with chlorate. Let's combine, let's use, how about we use sodium and combine it with nitrate. We'll do 5. Okay? And then let's see what happens if we try to match up tin, 2, and let's match that up with carbonate. And then let's do one more. Let's match up iron 3. Whoops, I'm writing the symbol here instead of the word. I want to write the words because I want you. Okay, so let's do iron. Let's write the word 3. And let's combine that with, if we use them all, let's use sulfate. That's a good one. Okay, so take a minute and try to combine all these and get the correct crisscross, and then we'll just come back and pick them up. All right. The magic of technology, that 15 minutes was less than a second. So we'll take them up. I'll go through potassium and phosphate first. Let's go down here. I'll jump around a bit. That's okay. So potassium, K, and it's in the +1 column, and phosphate, PO4 with a 3-. You just have to memorize that. There's no other way to figure that out. Then you do your crisscross. And so the 3 would come down here, potassium. And since you're crossing a 1, see the 1 that comes down here, you only need 1 phosphate. So there's no need for any brackets because we don't need to write the 1. So that's all we need to write. And remember what that means. It means that you need 3 little potassiums because each of those potassiums wants to give away an electron, right? And that means that 1 phosphate, this means she's looking for 3 electrons. And so there's 1, 2, 3. Everybody's happy if you have a group of 3 potassiums right here, and 1 phosphate. We don't show the 1. That's what it means. You have to remember what it means, because otherwise you just start crisscrossing all these numbers and it just becomes a meaningless exercise. We're talking about numbers here. Lead 4 and chlorate. Let's do that one. Lead 4, that means Pb. Remember, lead in Latin is called plumbum. So that's why it's Pb. Lead 4. And was it chlorate? Okay, chlorate. ClO3 with a -1. You have to memorize that. So here again, we have a 1 coming down the other way this time. So there's only going to be 1 Pb. We don't need to show the 1. But that 4 has to come down here. And that means we're going to need 4 of the chlorates. So we have to put the chlorates in a little group with a bracket like that, and then put 4 of them. The 4 applies to the whole big chunk. Okay? Oh, we forgot to write the names. So this one would be called potassium, and it's phosphate. You don't have to change anything in the name, just phosphate. And this one would be called, now be careful on this one, because lead's a polyatomic ion. You can't call it lead chlorate. It's got to be lead 4 chlorate, right? Because we've got to remember all the rules we've learned already. So this has to be called lead 4 because of the 4 that was right up there. Lead 4 chlorate. So we're getting lots of different rules to remember now. Okay, so far so good. Let's go back. Sodium and nitrate. This one should have been one of the simpler ones. Sodium is, whoops, that's an N. Let me rewrite that so it looks better. Sodium is in column 1, so it's a +1. And the nitrate is a -1. NO3 with a -1. So it's a perfect match, a 1 and a 1. So we only need one of each. When we cross down those ones, we don't need to write them. And so we just write it all together like that. And we call it sodium nitrate. So that one was easy. Sodium is not a multivalent ion. It's in column 1. It's not in the D block. Sodium nitrate. So there's no need for any brackets or Roman numerals. Got to remember all those things. All right, now let's go back up to tin, 2, and carbonate. Tin, 2, and carbonate. So tin 2, tin is SN, stannum. Tin 2 means that. And carbonate means this, CO3 with a 2 minus. Now here's one where you crisscross a 2 and a 2. Right? 2 goes this way, and this 2 goes that way, but in our minds we remember, oh, wait a minute, that can be reduced to 1 and 1. So really it's going to be a 1 and a 1. So in this case, we would just write tin, one of them, and the carbonate. And we don't need any brackets because there's only one, but we had to remember to do that little reducing. We want the lowest possible ratio, right? 2 and 2 in its lowest terms is 1 and 1. See, all the rules come together. And we would call this one tin 2 carbonate. We have to put the 2 here because tin is a multivalent metal. There's the 2. He's in the D block. He has more than one option. So we do it like that. All right. Now, let's go up here. What's left? Iron 3 sulfate. Last one. So iron 3, that means we know it's a 3 plus. And sulfate is SO4 with a 2 minus. You just have to remember it. Memorize them. There's no other way. The 3 comes down this way, and the 2 comes down that way. So what that tells us is we will need to have 2 iron atoms in this group, and we will need to have 3 sulfate ions. I should have said 2 iron ions, right? And then we have 3 sulfate ions. So we put the sulfates in the brackets to group them all together, and then we cross our 3 down, so we have 3 of them. And this would be called iron 3, little brackets there, sulfate. And that's the process. So far, so good? All right, we're going to stop this video here, and we'll practice a bit. And then we'll do another video where we'll explore some of the other polyatomic ions and how they work.